Hello everyone, this is Ketish here. In this video, I'm going to go through question number 3 from the AQA Combined Science 2022 Chemistry Paper 1 Foundation Tier. This question is on the topic of bonding structure and the properties of matter. So question number 3, this question is about structure and bonding. Figure 6 represents part of the structure of silicon dioxide. What type of structure is silicon dioxide? Now, if you look at this structure, it's very similar to that of diamond as well. Now, what you call this structure is where they've got three options: giant covalent, ionic lattice, and simple molecular. It is a giant covalent structure. Right? Ionic lattice is for sodium chloride, like it's made from ionic bonding. Simple molecular like water, oxygen, and so on. Each oxygen atom forms two bonds. What is the number of bonds formed by each silicon atom? Each oxygen atom forms two bonds. So for this, you need to go back to the structure to find the number of bonds formed by silicon. So, which is a silicon atom? This one. So if you look around silicon, you have 1, 2, 3, and the 4 bonds. So the answer is 4. Next question. Figure 7 represents part of a fullerene. Complete the sentence. Choose the answer from the box. So you have hexagons, octagons, squares, and triangles. The structure of fullerenes is based on, is it based on hexagons? I think so, because you can see here, if we look at one of this part, that's a hexagon. It's got 1, 2, 3, 4, 5, 6 sides, so it's a hexagon. Question 3.4. Complete the sentence. Choose from the answer from the box. Carbon, hydrogen, and oxygen. The fullerene molecule shown in figure 7 is made from atoms of. Now, they are made from atoms of carbon. Right? Question 3.5. What is the fullerene molecule shown in figure used for? Now, fullerene molecules are usually used for electronics. Right? 3.6. Figure 8 represents part of the structure of a polymer. So you have three polymer chains. What holds the atoms together in a polymer chain? So these lines, what are these lines called? They are covalent bonds. Ionic bonds are not found in polymer chains, so you don't find metallic bonds as well. Question 3.7. Complete the sentence. Choose from the answer from the box. Atomic, intermolecular, and macromolecular. In figure 8, the polymer chains are held together by what forces? We call them intermolecular forces. Next question. Figure 9 represents part of the structures of magnesium metal and magnesium alloy. So you can see the first diagram is magnesium metal, and the second is the magnesium alloy. So what are they asking? Calculate the percentage of copper atoms in the alloy. So they have given you 3 steps. So number of magnesium atoms in the alloy. So we are not looking at the magnesium metal, that's the alloy. So if I count the number of atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 atoms. You have 22 atoms. Number of copper atoms you have 1, 2, and 3. So 3 of them. Total number of atoms would be, you simply add them up, will give you 25. Percentage of copper atoms in the alloy. So in order to work out the percentage of copper atoms, so you would divide 3 divided by 25. That will multiply that by, because you want the answer in as a percentage, and that will give you an answer of, maybe I should actually write it on the top. Just bear with me 1 second. Let me move that. So there we go. Let's move aside. And that would be 12. 3 divided by 25 will be 12%. Let's check that with a calculator. So 3 divided by 25, multiply that by 100, that gives me 12. Okay. Explain why the magnesium alloy is harder than the magnesium metal. So use figure 9. So if you look at figure 9, they're asking why is the magnesium alloy harder than the magnesium metal. Now, metals are generally strong. So if you were to put force or pressure from the top, you're not going to be able to squash it, right? So they are actually strong. Now, problem is, if you put pressure from the side, what happens? Now, because all these metal atoms or the metal ions are in a straight line, this layer, this top layer, can literally slide over the second one. So you can actually get out of shape. Now, if you do the same thing for the magnesium alloy, right, because of the copper atoms, although it will try to push, this copper atoms will actually stop it from actually pushing the layers further, and that stops it from actually deforming. So it is actually harder because of this. So how do you write the answer? The alloy is harder because copper atoms are larger and are a different size. So you have to mention about the difference in size. So the layers of magnesium atoms are distorted, meaning they are not in a regular arrangement, and therefore the layers cannot slide easily. Right? That brings us to the end of question number 3, which was out of 13 marks. So each of those bullet points carries a mark. Just a little bit of notes on alloys and pure metal. So this is what I was explaining. In a pure metal, the layers can slide over each other if you apply a force from the side. But in an alloy, the presence of different metal atoms means the layers cannot slide over each other easily. That brings us to the end of the video, and I will see you in question number